Good afternoon, guys. It's always good to have the last session of the day, right? So everyone's gone, so already drinking downstairs. My name is, you can go if you want to. My name is Yvo Wiskerker. I'm a solution architect working for Cisco, the north region of EMEA, which is basically the Benelux and the Nordics. And my main focus for the last couple of years have been open source and in general now, especially OpenStack. So every customer that shows interest into running open source and especially OpenStack somehow comes my way, and I sort of help them through all the paces that we've gone through. So first let me get a show of hands. Who of you have seen the session this morning? Because I saw a couple of guys coming in later. Yeah? Okay, good. Who of you guys knew that Cisco was in the server market? Oh, that's quite good. So I've done my work well. I've been working with Cisco for about 5 years now. When I joined Cisco, we just released and just introduced UCS, the Unified Computing System. I've quickly added some slides, and the reason why I did that is I want to clarify a couple of things. And I'm not sure if you guys are up for it, but most of the sessions that I've seen today are not that technical. If you're into that, I'm going to give you a treat, because I want to go a little bit into a deep dive into what we do currently and what we've introduced in the last couple of months. So let me begin with the picture that Mark showed this morning as well. If you look at OpenStack in general and the things that we've been doing with it, we've had infrastructure products now for, well, like I said, 5 years ago we started with the server market, and we basically changed the way that we look at servers, how they are deployed, what we're doing with them, why are we going through the pain over and over again, and we tried to fix a couple of things. And the things that we fixed actually were very good and actually fits right into the point where you can attach OpenStack. So the way we approach physical server hardware is almost the same as if you would work with a virtual machine. The only difference is you can't change the CPU, you can't change the memory, but everything that a server is, does, and can do, and can go to, we can actually influence through an API. So that actually fits in this bottom layer of this stack, and different services that we've been working on, different projects within the OpenStack stack basically, have found their way into different development programs within Cisco. And it wouldn't surprise you that networking is obviously one of them, right? Neutron has been basically our default gateway, if you want to. We've been working on plugins to actually get our products up there and actually show our capabilities in the infrastructure. Ironic is basically one of the latest things that we've been working on, and that ties into what I've just said. We can do a declarative, we can actually make hardware declarative. So the configuration that you do for physical service, you can actually do through Ironic and actually get that infrastructure up and running from an OpenStack perspective. So one of the ways that we actually use that internally right now, and it's still in prototype phase, but one of the ways that we use that internally is we can actually build a cloud of physical boxes. Now, everyone would think that's a way back. No, it's not. Look at your own infrastructure. See how many physical workloads you still have. How many of those physical workloads are specifically to one customer, one business unit, one specific application? Why wouldn't you want to do that through an API that's readily available? Right? So that's the reason why we've actually tied into that one. From a Nova Compute perspective, it's basically the same thing. We want to have the tie-in into the Neutron. Same way we do that with Neutron, the Neutron service. We do that with Nova Compute as well. We want to know what kind of requests come in, and we want to have a more flexible way of dealing with our physical infrastructure. Now, without further ado, just a little bit about UCS. So Mark told you that, he showed the slide, but he didn't really tell you that much about it. One of the things we did is we captured the things that matter to a server and make a server what it is and does and can boot from and can go to, actually capture that in a service profile. That service profile is just nothing more than a statement. It's a policy. You apply that to your server, but the way you do that is basically similar to the configuration file of a virtual machine. So you can copy it, you can clone it, you can do whatever with it with that specific service profile. It's not attached to hardware yet. But we can take it off hardware and put it on another piece of hardware, which makes it really interesting because I've got a couple of customers that do that, for instance, for their Oracle workloads. Oracle's not happy with that because we actually can do failover of hardware to another data center without them having to pay double licenses, which is pretty cool because you can just shut down the server, move it over to another location, boot it up there, as long as you have the storage replicated, obviously. That is so simple. I can capture that in about 10 rules of Python script, or actually do that with any kind of orchestration software. So we take the comparison with a SIM card, an identity of a phone, and I've actually put an asterisk behind it because you also need your Apple ID or your Google ID. But if you lose your phone or you drive over it like I did a year ago, I seriously did. I drove over my own phone. I dropped it, I forgot that I dropped it, and I thought, what was that bump? The next day I went to the store, bought a new phone, got the same SIM card, even my SIM card was broken. So put in a new SIM card, logged in with my ID. A couple of minutes later, basically the installation started installing again. So that's the way that we do that with the UCS service profile. The only thing that matters is that SIM card. The only thing that matters is that UCS profile. Now, in that sense, we get a programmable infrastructure. And that programmable infrastructure gives me the opportunity to basically define what that hardware needs to do. And how does this all fit into an OpenStack environment? Now, like I said, we have that tie-in into Ironic, for instance, to do this with bare metal. But also for the deployment of infrastructure, I don't need specific specialists anymore to do the initial installation of my compute nodes, of my storage nodes, of my network nodes, or any other type of service that I need. I can just have, for instance, a partner that does the physical placement of the hardware, and the rest I do somewhere else, right? From orchestration software, from the other side of the world. I'm actually using, at this point, I'm using about 40 servers right now that I can do anything with, but they're across the pond, right? They're in North Carolina right now. And I can do whatever with those things. I can shut them down, move them around. And if I need new physical hardware, obviously, I'm just calling them up and say, I want to have the new version of that blade. I want to have 1 gig of memory, 1 terabyte of memory. One of our new servers does 1.5 terabytes because I want to try something. And then I've got one of the guys, and they're good guys, but they're sort of trained monkeys, right? The only thing they do is just switch servers all day. And that's all they do. They replace that server, put in a new one with that amount of memory, and then I go and do my thing. Okay, so before I take up too much time on this topic, because these slides I added later on, we can move these things around. We can place them anywhere, like I said, and we do that by having this different subject matter experts configure their own things. So I can have a storage subject matter expert define what kind of worldwide profiles I need. I can have my network subject matter expert define what kind of quality of service specific settings I need for what server. And this is how Ironic looks at this time. It's not very sexy, but the only thing we get is we get a sort of an extra tab where you can see the available servers, and in this case you see what kind of chassis, what kind of blade, you see the CPUs and you see the RAM, and I can attach certain workloads to those. These are actually presented to a tenant in OpenStack as well. So if a tenant wants to deploy a physical workload, he gets, in this case, a couple of servers that he can use, and he takes off glance the image that's been typed physical workload, so bare metal, and that gets deployed and basically comes onto this server. Without Pixie boot, without any installations, it's basically moving an image and making it available to that server. Okay, so that's for that. Now my real talk, right? So one of the things that we've obviously been doing for 30 years is networking. And one of the things that we've been doing really good in networking is making it far too complex for ourselves. And what we did a couple of years ago is we took a step back. And I believe it was Einstein that had some sort of saying, and he said, you can never solve a problem from the same level of consciousness that created that problem. So in other words, you need to take a step back or bring some new guys in and have them look at the problem. Now, one of the things that we've been doing over the last couple of years, we started making subnets, right? IP addresses, and it needs to be carved up in different things. Well, that wasn't too shabby, right? If I changed my IP address, I could go everywhere. I could get conflicts and stuff. So we added VLANs. And after that, we said, well, we need some layer 3, and we need some security on that as well. So we started tying all these things together. Made it a really big mess. Now, when security comes in, I've got a couple of customers, and I'm not naming names, but I've got one customer at 15 million rules of firewall code, right? 15 million rules. What they do, they don't take the rules away anymore because they're afraid if they take them away, nothing's going to work anymore. So that sort of stuff is what we've basically created over the last couple of years. Now, in order to change this, there's a lot of great tools out there that can simplify firewall rules, and you can do all kinds of funny things. And this is the same message that everyone's basically had over the last couple of years. Now, if you look at the two different languages that we're actually talking about, the network guys talk a certain language, and the application guys, so like it was mentioned, for instance, by Koen, what's the core of your business, your applications, your services? Who is writing those? Is that off-the-shelf software? 90% of it, maybe. But application guys do not talk network. Most of them don't. So there's a human translator in there. And I'm going to be the last one that says that Cisco hasn't been a part of this problem, because we've created a huge community of guys that had gone through all kinds of training and CCIE stuff and everything. Really cool, really expensive guys. So that human translator is basically slowing down the application delivery in your organization. So in order to change that, we've actually gone through a couple of steps. And we've said that today's software-defined network model is basically shifting what we've actually created in real life up to a virtual layer. We're still doing the same thing. We're still creating VLANs, we're still creating all kinds of other problems, but we're shifting it up one layer. But now I've got two problems. I've got my physical layer and I've got my virtual layer. Now, one of the issues I have with that personally is that either one is going to suffer. So security-wise, your infrastructure is going to suffer on the software-defined side, which is mostly not the case because that's sexy, that's new. But on the physical layer, that's going to suffer because you're going to wipe all the security rules because we don't need it anymore, we've got everything in software-defined. But how much workload do you still have in your data center that is not virtualized? That's quite a bit if you're comparing it to the amount of virtual machines that you have. So we've taken one step further. We said we're going to make this infrastructure application-centric. We're going to look at the applications, and no matter where it's running or what it's doing, we can apply the policies that you define, onto this infrastructure. And one of the ways we've done that is we've basically said everything that you connect is not going to go anywhere. In a normal network, buy an off-the-shelf switch, plug in a server, plug in another server, they're going to be able to talk to each other immediately. In our case, what we've said, no traffic is going to go from one port to the other until it's defined, which means that inherently it's more secure. So anything that you take away from the configuration obviously is going to drop every connection. It's not going to be able to communicate anymore, which is a better way of doing it from a security perspective. Now, we did the same thing with this as we did with the UCS service profiles. We actually put this into what we call an application profile or an application policy. And in this case, there's a three-tier application, and I've got a web, an application data server, and I've got a database server. Now, what I want to do to that, I want to make contracts between them. What are these allowed to send and receive? And I put these in between, And I can also, it's not just firewall rules. I can actually bend the traffic over to, for instance, a load balancer. And if I do that, I bend them over to a load balancer, the application is not going to know about it. I don't need to create an extra VLAN going outside of the infrastructure, going back in with another VLAN, which I usually have to do if I did that in a traditional way. So the amount of VLANs that I have is going to skyrocket if I don't do it in another way. Who here has an infrastructure with more than 5,000 VLANs? 2,000 VLANs? 1,000 VLANs? So who here is service provider? Okay, this is a service provider. I've got one service provider customer that has about 5,000 VLANs. Right, so they've got a serious problem because in some cases they're running out of VLANs to use. Now, because we do this differently, because we see all the traffic, this is data center traffic, so everything in the data center we see passing through these switches. We can bend that traffic. We used to be able to do that, or we're still doing this in the virtual world, but we just used this kind of technology and moved it to the physical world as well. Now, one extra, I need to be careful of the time, to be honest. One of the extra things that we included as well in this infrastructure, because we see all that traffic coming by, is we can have telemetry on that infrastructure. We can see real time what the latency is on packets. We can see real time what the amount of drop packets between two links are, which is something that nowadays you have to do investigatively, right? You have to go in and test and troubleshoot and see, okay, well, the latency on this link is now 25 milliseconds. Well, what was it an hour ago when you had a problem with the application? I don't know. Now, that sort of thing we actually do in this infrastructure as well. Now, this is sort of an explanation on how that looks. We call these endpoint groups, which is basically an equivalent to a VLAN, but it's not a VLAN because we can identify the different workloads by, for instance, DNS name or IP address or virtual port or virtual identifier even in virtual worlds. And there's a couple of contracts in here, just inbound only. And if I add a new application server, as long as it is part of those identifiers in that application group, it immediately gets all the policies pushed, no matter if it's a virtual machine or a physical box. Now, this is how we map that to the traditional way that OpenStack works with this. In OpenStack, you've basically got the simple constructs, right? You've got a network, you've got a subnet, you've got a port, and a router. Today, we actually map this. So the policy is basically mapped to, in this case, a network. The endpoint groups is mapped to a subnet, and an endpoint is connected to a port. That is today's way of working. Now, what we've done when we started working with the OpenStack community again and said, okay, we came up with this new infrastructure and this new way of working with networking. One of the ways that we want to change this is we want to change the way that you model your network. Because in OpenStack, you still model network, router in between. Oh, where do I need to put my machine if I want to have a load balancer server, stuff like that. We said, okay, if we want to change that, then we need to submit a new way of working. And that's what we've done for Juno. So the Juno release will have the group policy API. And the group policy API will actually work in the same way as I just explained to you. You will model your network, your initial network, the way you used to now. So you create a network, you've got an external network, all that. But all the workloads that you put on that infrastructure will actually work through the group policy API. So you're able to apply those policies to the different machines that you have. And this is not Cisco specific. This is not anything that we've done proprietary. Better yet, we've created something else, and that's called OpFlex. I'm not going to bother you with that, but OpFlex is a protocol to actually be able to communicate those policies with, for instance, Open vSwitch. The Open vSwitch project has actually adopted OpFlex as one of the new features. So there's an OpFlex agent in that. Now, this is the old way of working, still works. So how am I doing on time? 9 minutes. I've got about 20 slides left. Now, looking at the way that we've set it up right now, right? So this is today's way of working. And the initial installation, basically what we're waiting for right now is a Juno release. So when Juno comes out, we'll have that group policy API and you'll be able to use it. Doesn't mean that you have to have Cisco hardware to use it. Any other vendor that wants to write a plugin for the group policy API can do that. Now, it wouldn't be a surprise that we're in sort of a competition with a hypervisor vendor, which is, funny enough, my former employer. They can tie into this as well if they want to, from an OpenStack perspective. And that's Cisco's role, basically, in the OpenStack community as well. So in the foundation, we've got Lou Tucker, who's part of the board. If you look at this infrastructure right now, you see, for instance, here under here, all the hosts have their IP tables. Their Linux IP tables will actually provide some of the security. So the security groups that you define now are going to be applied here. You can still do that. You can still work with that. But this is what's going to happen. And I don't know if you all can see this, but from a standard way of working, you actually create your networks, right, in a normal fashion. The policy get applied to what we call our controller, the APIC controller. The controller actually creates the endpoints, and in this case, there's an allow any to make sure that there's at least some traffic flowing. This depends obviously on the policy that you use. Policy gets pushed to the infrastructure, and you can be up and running. One thing to mention though is that in our traditional networking setup, so non-ACI, up till now, you could connect any switch in any way you would like. You could make a mess. A funny mess. As a technology guy, I love that, right? The more complex it is, I was, what the hell did they do here? I like that. But sometimes it's not the way you should do it, and it creates a hell of a lot of problems in later on. An ACI fabric can only be connected in one way. There's only one way to connect it. So there's no question about it. This connection goes here, the other one goes there, done. That's the way that we actually set it up right now. Everything else is done by these policies. Now, if you look at the new way of working, and you see that quick change up top, is that the new way of working from the Juno release and on, you can actually do that here. There we go.
Dames en heren, u wordt vriendelijk verzocht om naar podium 1 te gaan voor de afsluitronde. Podium 1. Dank u.
Right on time. Thank you, guys. If there are any questions, I'm going to be downstairs. I've got a LinkedIn page as well, like Koen said. I'm not sure if you guys catch my name, but there's only one Wiskerker, W-I-S-K-E-R-K-E within Cisco, and there's only one Yvo with a Y within Cisco, so that's very easy to find. Thank you very much.